Welcome to the fourth video of time complexity basics. In this video, we'll go over quadratic time complexity as well as some code examples. Let's get started. Remember, quadratic time complexity, or O to the n squared, just means that as our input size n grows, the time taken by the algorithm grows quadratically with the input size n. And just a little side note, quadratic time complexity is the most common in the set of polynomial time complexities, O of nc, where c is greater than 1. What this just means that polynomial time complexity includes everything like O to the n squared, n cubed, and n to the fourth, and then everything just goes on to infinity. But the most common ones are these two, and n cubed is not even that common. And n squared is the one that we'll be going over this video, but just remember that there are more than just quadratic time complexity. There could be cubic or quartic time complexity as well, but this one is just the most common. Let's get started with some code examples. We have an array of just some random numbers that I created, and then we'll do two things. The first thing is just a little example to show how O to the n squared looks in code. And the second one is a more practical example, like bubble sort, where we'll just sort this array. So let's start printing out all the pairs of an array. I'll just create a new variable called n, and this will just stand for the length of our array. Actually, let's change this to r. Alright, so let's create a function that says print pairs. We don't need to pass in anything because it's defined like above, so we should be fine. So to print all the pairs, we need to iterate over the whole array n squared times. But what that means is that we need to start at an index, and then we need to go through all the other indexes. So pairs could be 5, 2, 5, 9, 5, 1, 5, 5, 5, 6. And then after all of the pairs of the first index are done, we need to go to the second index, which is 2. So those pairs would include 2, 9, 1, 5, 6. And then, okay, one thing that we need to note, even when we go to the second index, we need to start our second loop at the first index. So a pair could be 5, 2, but the reverse could also be true. So 2, 5 is also one possible pair. Let's get started coding. So to iterate over the first indexes, we'll do range n. So what it'll just do, it'll just pass over the array, and then I is our index, so we start at 5, and we need a second loop to go over the rest of the indexes. So for in range n, and then we need to start this, actually that should just be fine. And now we can just create an f string of array I, and then array j. And now we can just call this function, and then let's run this. So yeah, we get all of the pairs of an array. And as you can see, this is n squared because we're passing over the array n times, and then we're inside the n times, we're passing it over n times again. And that just means that we're passing it, in worst case, we pass it n, and then we multiply that by n as we're passing it over every single time. So n times n is just n squared, which is why we call it O to the n squared. So now we know what quadratic time means. Let's do a little bit more practical example, and that's bubble sort. So bubble sort is just a basic sorting algorithm where it checks each index with the rest of the indexes, and it swaps two elements if this one is greater than the next one. So for example, we start at 5, and then we go towards we just check the other indexes. So we check if 5 is greater than 2. So 5 is greater than 2, so we swap these. So now it becomes 2, 5. And then we just swap, since we check the next index, we check 5 against 9. And since 9 is greater than 5, we swap those again. Okay, I didn't want to do that. So we swap those, and then it just keeps repeating. Let's get started coding it out. So let me just create a new function called bubble sort. We don't need to pass in the array again. So we need to do the same thing. We need to do and wow. Let me move these down here. Perfect. And then now we have our starting indexes, and then let's create our inner loop to access the other. So here, this is kind of confusing, but this range will be from n minus I minus 1. I'll explain what that means in a little. And then here we can just check if array j is greater than array j plus 1. Where is my bracket? Then we just swap these around. So let's create a temporary array j equals array j plus 1, and then array j plus 1 will equal to the temp. So this should work. Let's test if this works. So bubble sort, and then we'll print the array. So yeah, here you can see that our array is fully sorted. So what this n minus I minus 1 does, or I'll explain what the minus 1 does right now. The minus 1 just makes sure that we don't go out of bounds since we're checking for the next index. And this I just means that we subtract our starting index from the length. So our first index would be 0, and then if we subtract 0 from the length, we'll go through the entire array. But when we go past our first iteration, the last number inside of our array should already be the largest, and we don't need to check the largest again, because we know that that's already the largest number in the array. So the next iteration, it'll be 1, so we subtract 1 from the length of the array, and then we only need to check up till the one spot behind the largest number, because we already know that this one's the largest number. And yeah, that's how you do bubble sort. And this bubble sort algorithm is O to the n squared, because we need to iterate over the array n to the n times, or n times n times. So the outer loop we iterated over n times, and the inner loop we iterated n times again. So n times n equals n squared, and then this is just denoted by O to the n squared. Yep, and that's what quadratic time complexity is. Thank you.